everybody. Today we're going to talk about rational expressions. A rational expression is the quotient of two polynomial expressions. So that could look like 2 over x, or maybe x plus 8 over x squared plus 9x minus 2, or even y over y plus 5. So what we're looking for is two polynomials that we're just taking the quotient of. As we go through this section, our main goal is really to simplify rational expressions. So this will involve factoring out the numerator and denominator and then looking for any common factors in the numerator and denominator that we can cancel out. So the rest of this video will just be lots of examples where the rationals will look a little different. So sometimes just like this, where I have a rational expression, other times we'll add, subtract, multiply, or divide. Let's get started with 4x to the 8th plus 24x to the 6th plus 28x to the 4th over 12x to the 5th. When I look at this one, I notice that 4, 24, and 28 are all divisible by 4. I also notice that they're all powers of x. And the bottom, 12, is also divisible by 4, and we have powers of x. So what I'm going to do is I'm going to take the 4 out of the top, and I'm also going to factor out the highest possible power, which is 4. That's going to leave me with x to the 4th. 24 divided by 4 gives me 6. And then my new exponent, 6 minus 4, is 2. The 28 divided by 4 is 7. And the x to the 4th is just on the outside. In the denominator, I really want to repeat that process of factoring out 4x to the 4th. So 4 goes into 12 3 times. And then if I subtract 5 minus 4, I just get this power 1. Now I can cancel out 4x to the 4th and 4x to the 4th. My answer is x to the 4th plus 6x squared plus 7 over 3x. It doesn't look particularly pretty, but that's not what we're looking for here. We're not trying to see how pretty it is. We just want to say how much smaller can we make it. So let's try that with this one. I have 40 over 15 minus 10x. In the denominator, 15 and 10 have a common factor of 5, so I'm going to take that out. 15 divided by 5 is 3. 10x divided by 5 gives me 2x. So I'm going to repeat that in the top. I'm going to divide by 5, and that's going to give me 5 times 8. 5 matches 5, so I cancel it out. My reduced rational is 8 over 3 minus 2x. Very similar, this small little rational of 18x over 24x squared minus 6x. I really kind of do a little look at it first to say, okay, what goes into everything? So 6, 24, and 18, I think let's take a 6 out. They all have an x, so let's also factor the x out. So if I factor 6x out of 18x, it leaves me 3. If I take 6x out of 24x squared, I get 4x. Then negative 6x divided by 6x gives me negative 1. This common factor of 6x cancels. I'm left with 3 over 4x minus 1. The next one says 8x plus 80 over 12x plus 16. Now, when I look at the 8x plus 80, I notice that I could take an 8 out. But instead, I'm going to also look at the denominator, 12x plus 16, and think I could divide out a 4. My plan is to take a 4 out of top and bottom. So 4 out of 8x plus 80 gives me 2x plus 20. And then the 4 out of the 12x plus 16 gives me 3x plus 4. So I'm going to cancel the 4, cancel the 4. I end up with 2x plus 20 over 3x plus 4. So even though I could take the 8 out, it really didn't help me to do that. I want to take out what they have in common instead. This one I've switched over to y. I have y cubed minus y to the 4th over y squared. So everything is a power of y, and the largest power in the denominator is 2, so let's factor a 2 out of the top. Y cubed divided by y squared is y. Y to the 4th divided by y squared is y squared. That cancels out, so I end up with y minus y squared. Notice this time I didn't really have anything left in the denominator. I could put a 1 if I wanted to, but when I'm just dividing by 1, it's okay to drop the denominator altogether and just leave it nicely as y minus y squared. Now look at this one. I have x minus 2 over 2 minus x, and hopefully when you look at it, you're like, that looks really kind of the same. So let's just rewrite that a little. Let's write x minus 2, and I'm just going to rewrite the denominator to make it negative x plus 2. I want to put the x's first and the number second. Now, again, it looks close, but not exactly the same. So what I'm going to do is I'm going to factor out a negative 1 in the denominator. So negative x divided by negative 1 is x, 2 divided by negative 1 is negative 2, and now it looks exactly the same. I have x minus 2 on top, I have x minus 2 on the bottom, so let's cancel that out. What do I really have left in the top? Well, I have a 1. On the bottom, I have a negative 1. 1 over negative 1 is negative 1. This is something that you kind of see happen a lot. So if you have something like a minus b, and you would like to flip it over to b minus a, you're going to do negative 1. So you can think of factoring out a negative 1 or multiplying by a negative 1 to get the numbers to reverse. So here's a second one, just like that, 3x minus 4 over 4 minus 3x. So now that we know this cute little rule, I don't have to kind of flip it around and think about it. I'm just going to take the negative 1 out. I have 3x minus 4. That becomes negative 1 when those two cancel. If you wanted to do it the long way, like if you need to see that one more time, you can definitely do it that way. I could put the negative 3x first and then have plus 4. Then I could take out the negative 1. I get 3x minus 4. That would cancel, and you get the negative 1 answer. It's nice when you see little tricks. That way you can use them and save yourself some time when you're doing homework and quizzes and tests. In this next one, I have x over 4 times 32 over x plus 5. I want to remind you, when you multiply fractions, you multiply the numerators, so I would have AC. I multiply the denominators, I would have BD. What you want to do, though, is see if you can cancel anything first. So the x and the x plus 5, they don't really have anything in common. But 4 and 32 are both multiples of 4. So I'm going to say 4 goes into 32 8 times. That leaves me with 8x in the numerator, x plus 5 in the denominator. Next, I have x squared minus 4 over x squared plus 3x plus 2. So the x squared minus 4 becomes x plus 2, x minus 2 is a difference of squares. X squared plus 3x plus 2, that's x plus 2 times x plus 1. My factors of 2 that add up to 3 are 2 and 1. I can see this x plus 2 cancels. So what do I have? I have this nice little x minus 2 over x plus 1. Well, let's take a look at x plus 6 over x squared plus 4x minus 12 times x minus 2 over x plus 2. The x plus 6 is fine. It doesn't simplify. But I look at the x squared plus 4x minus 12, and I think, well, what factors of negative 12 would give me positive 4? And that would be x plus 6 times x minus 2. That's multiplied by x minus 2 over x plus 2. So hopefully you notice there's a lot to cancel. This x minus 2 cancels x minus 2. X plus 6 cancels x plus 6. So the numerator is just a 1. The denominator is x plus 2. Let's try some with division. This is x over 7 divided by x plus 2 over 28. Now, really important to think about when you're doing division, so like a over b divided by c over d. You're going to leave the first term alone. It'll still be a over b. The division turns into multiplication, and you are going to flip the second term. So now I have a over b times d over c. So for our example, x over 7, I'm going to make it times 28 over x plus 2. So division becomes multiplication, and we multiply by the reciprocal. 7 goes into 28 4 times. My new numerator is 4x. My denominator is x plus 2. Let's try that with x squared plus 6x plus 9 over x squared plus 12x plus 27 divided by x plus 3 over x minus 8. So I'm going to start by factoring. Factors of 9 that add up to 6 would be x plus 3 and x plus 3. Factors of 27 that give me 12 are x plus 3 and x plus 9. I take this division, I turn it into multiplication. Now it's going to be x minus 8 over x plus 3. So we did a bunch of stuff here, right? We factored, we changed it to multiplication, and we put in the reciprocal. So now we start looking for things that match. Well, I have an x plus 3 and an x plus 3. Then I have another x plus 3 with another x plus 3. My final answer is x minus 8 over x plus 9. Now I have x squared minus 8 over x squared plus 13x plus 40 divided by 4x over x plus 5. I want to start by looking at x squared minus 64, which is x plus 8, x minus 8, and then I have x plus 5 and x plus 8. So I looked for factors of 40 that add up to 13, which would be 8 and 5. That divide changes to multiplication. I have x plus 5 over 4x. So I see one of the x plus 8s cancels this other x plus 8. The x plus 5 on the numerator cancels the x plus 5 in the denominator. I'm left with x minus 8 over 4x. Let's look at adding two rational expressions. I have 9 over x plus 12 over y. Now, when we get to addition of rationals, we need a common denominator. So here they don't have anything in common, so I'm going to multiply kind of by the opposite. So the x, I'm going to multiply y over y. The y, I'm going to multiply x over x. So I have 9y over xy. I have 12x over xy. When I put these together, I have 9y plus 12x over xy. So it doesn't really look simpler or smaller, but we did take it from being two separate expressions and put it together as one expression. So same thing here. I have two expressions. I have 1 over x and I have minus 7. What I want to do is put them together. The common denominator here will be x. So I have 1 over x minus 7x over x. This condenses to 1 minus 7x over x. Let's try 2 over x plus 6 plus 4 divided by 2 minus 3x. When you look at this, everything is simplified. X plus 6 doesn't have any factors. 2 minus 3x doesn't have any factors other than like 1 or negative 1, right? And we don't need to mess with that. So what I have to do here is think about what's going to be my common denominator. And my common denominator is going to be x plus 6 times 2 minus 3x. This time I can kind of think about this 2 needs to multiply by 2 minus 3x. I'm going to write it that way. Plus this 4 needs to multiply by x plus 6. So you can write it the long way where you write the 2 over x plus 6 and you say I'm going to multiply by 2 minus 3x over 2 minus 3x. And then you do the same thing with the 4 over 2 minus 3x. You say I'm going to multiply by x plus 6 over x plus 6. So you have to decide how many steps you want to do and how many steps you really need. If you need the extra steps, you take the extra steps. There's nothing wrong with doing more. Now I need to distribute. So 2 times 2 is 4. 2 times negative 3x is minus 6x. Then I have 4 times x, that's 4x. I have 4 times 6, that's 24. I am not going to multiply the bottom, so I am just going to leave the bottom in factored form. Let's combine like terms. I have negative 6x, positive 4x, that gives me negative 2x. I have a positive 4 plus 24, so that's plus 28, over x plus 6 times 2 minus 3x. So completely fine to leave this in factored form. I wouldn't multiply the x plus 6 times 2 minus 3x. Let's do a little more addition. I have 2 over x plus 3 plus x plus 15 over x squared minus 9. So I have 2 over x plus 3. I can factor out the x squared minus 9 as to x plus 3, x minus 3. So part of it they have in common. There's an x plus 3 in both. I'm missing the x minus 3 on the left, so I'm going to multiply the numerator and denominator by x minus 3. Let's multiply this through, so we're just going to distribute. I have 2x minus 6 plus x plus 15 over this denominator of x minus 3, x plus 3. I'm going to add the x's together, so 2x and x, that makes 3x. 15 minus 6, that's a positive 9. Over x minus 3, x plus 3. Now this one, I noticed that 3x plus 9, they have a 3 in common. So I'm going to take the 3 out. It gives me x plus 3. So here's x minus 3, x plus 3. Now I can cancel an x plus 3 top and bottom, and my final answer is 3 over x minus 3. So I hope you're noticing that each of these little problems has different steps that you're going to do. You kind of have to keep pushing to the next step and seeing, does it look like something will simplify? Is there something else to do? So there's not a number of steps you do. It's just to keep pushing as far as you can. Here's our last one. I have 1 plus 5 over x divided by x plus 1 over 10. So we call this a complex fraction. It is a fraction within a fraction. And really what I want to do is I would like to clear the fractions. I don't want to have a double fraction. So what I look for is what's in the denominator. So I know I have an x in the denominator. I also have a 10 in the denominator. So I'm going to multiply the numerator and denominator by 10x. It's important that I'm doing the same thing to both. That way 10x over 10x is 1. When I multiply by 1, I don't change the value of the expression. I just kind of change the look of it. I need to distribute. So I have 1 times 10x plus 5 over x times 10x. Same thing in the denominator. I have x times 10x plus 1 over 10 times 10x. Well, let's see what that looks like. 1 times 10x is just 10x. The x cancels the x. 5 times 10 is 50. And the denominator, x times 10x is 10x squared. The 10 cancels the 10, so I just have x. Now, if you wanted to see if you could push this any further, you could take a 10 out. You would have x plus 5. You could take an x out. You have 10x plus 1. Nothing cancels. Nothing else happens. This is more of a verification for us that we've gone as far as we possibly can. So you might find it easier to factor after you've made your other simplifications, just in case there is something that will cancel out. I know this is a little long, it gets a little sticky, but this is something, it comes with practice. I like that it reinforces the factoring polynomials that we did earlier, and it will continue to pop up. This is not the last time you're going to see rational expressions. It's just the first little step of introducing us to them again and thinking, how do we deal with these kind of big expressions?